When using a microcomputer, it is possible to write and execute programs without the use of an external memory storage device. However, without memory storage, the program and all its data is lost when the computer is turned off. You could, of course, obtain a reproduction of the program and data by making a hard copy using a line printer. But every time you wish to use the program, you would have to retype it into the computer. Some programs are simply too long for this to be a convenient arrangement. So some method is needed to store information for easy recall and use. In the early days of computing, the large mainframe computers used magnetic tape on a reel-to-reel arrangement similar to that used on tape recorders. But one of the main drawbacks to magnetic tape was the data had to be stored in a sequential manner, and it had to be accessed in the same manner. While this method was adequate for many uses, it was extremely slow. This method of memory storage is still used for many data processing applications today. When microcomputers first appeared, they also used magnetic tape as the storage medium. But they used it in a form utilizing the popular audio cassettes and player recorders. Most microcomputers still permit the use of cassette tape as one method of data storage. To help overcome the dual problems of slow speed and sequential access inherent with tape memory storage, engineers, taking their cue from the phonograph record, designed a flat aluminum disc, 18 to 30 inches in diameter, and coated it with a magnetic oxide similar to that used on tape. The read-write head was designed to move over the disc and could be positioned at any point the operator desired. This, in effect, gave total random access to the entire disc instead of only sequential access. Engineers soon created a miniature version of the hard disk drive for use with microcomputers. The new disk drives were reduced in size and cost and used a magnetically coated circular mylar disc permanently sealed in a square envelope as the storage medium. Because the new 8-inch and later 5 1/4-inch diskettes were flexible and were not rigid as were the large mainframe disks, they soon gained the name of floppies. First, let's take a look at the floppy or diskette itself. Compact and inexpensive, it can store a great deal of information. For example, a 5 1/4-inch diskette can store from 80 to over 200,000 bytes of information, depending upon its configuration and manufacturer. The diskette is permanently sealed in a low-friction protective jacket in which it can spin freely. It should never, under any circumstances, be removed from this jacket. The oblong window cut in the protective jacket allows the disk drive read-write head to access the diskette to either read existing data from the diskette into the computer or to write new data onto the diskette from the computer. On one edge of the jacket, blue arrow, is the write protect notch. On the 5 1/4-inch diskettes, when the notch is uncovered, data can be added or changed. When the notch is covered, data cannot be added or changed, and the diskette is said to be protected. On the 8-inch diskettes, the system works in the opposite manner. The diskette is protected when the notch is uncovered. It can be written onto only when the notch is covered. Before a diskette can be used for data storage, it must be formatted. A special program forms or formats the undefined magnetic particles of a new or blank diskette into a series of concentric circles known as tracks. The number of tracks on a diskette will vary with equipment manufacturer, but will range from 35 to 80. The diskette is further divided into pie-shaped wedges known as sectors. Typically, diskettes are divided into from 9 to 18 sectors. Each sector of each track will hold 256 bytes of information. Thus, a diskette with 40 tracks and 18 sectors can hold approximately 185,000 bytes of data. Diskettes require special care and handling if they are to function properly. They must be handled only by the jacket. The exposed magnetic area should never be touched. They must not be bent or folded. They should be protected from dust, dirt, and even cigarette smoke. Never write on a diskette label with any instrument other than a felt marker. Failure to observe these precautions can result in a malfunction problem called a crash, which can result in either a total loss of information or a scrambling of data. There are hard crashes and soft crashes. A hard crash usually occurs when the diskette is physically damaged in some way, such as being scratched, creased, or folded. A physically damaged diskette can also cause serious damage to the delicate read-write head, thus rendering the disk drive inoperative. It is best to discard a damaged diskette so that it cannot be used by accident. A soft crash usually occurs when the operator fails to follow proper operating procedures and accidentally overwrites existing data, usually the directory tracks, scrambling the data on the diskette. To appreciate the results of a soft crash, imagine picking up a telephone book in which the listings are not in alphabetical order, the pages are misnumbered, addresses are where names should be, and the phone numbers have middle initials. That is the state data on a soft crash diskette would take, totally useless. In order to make the diskette operate and to access the data it contains, the microcomputer needs an additional peripheral device. That device is known as a disk drive. Most microcomputers use one or more externally mounted disk drives, as shown here. However, some computers have provisions for one or two disk drives to be built into the computer console. The diskette is mounted on a hub inside the disk drive, somewhat in the manner that a record is placed on a 45 RPM record player. However, instead of rotating the disk at only 33 or 45 RPM, as does a record player, the disk drive rotates the diskette inside its protective jacket at 300 RPM. The read-write head is mounted on an arm, somewhat analogous to the tone arm on a record player. This arm is attached to a stepper motor. A stepper motor uses a lead screw to position the read-write head at the desired position on the diskette. The stepper motor and lead screw allow both extremely accurate and exact repeatability of read-write head placement. Exact repeatability is the key to successful disk operation. It is absolutely essential that the head can be positioned accurately at the same place each time called for, in order that data may be placed and recovered from the diskette with precision. The storage of data on a diskette is a much more complicated matter than is the simple transfer of data to and from a cassette tape. In order that the read-write head will know where to find the desired data, special software known as a Disk Operating System, or DOS in computer jargon, is required to make the disk drive function with the degree of precision required. The DOS is usually contained on a special diskette. Before it is possible to operate a microcomputer with a disk drive, it is usually necessary that the DOS master diskette be in the first drive of the system. Some microcomputers require that the DOS diskette remain in that drive during the entire period of operation. The disk operating system is a comprehensive set of routines and file management utilities that make it possible for a computer system consisting of various input and output devices, disk drives, and programs to interact efficiently and with apparent simplicity. First and foremost of the programs contained on DOS is the executive or supervisory program, which is loaded into RAM at power up when the diskette is initialized. It remains in RAM all the time the computer is operating. It includes certain system routines, tables, pointers, and the input and output drivers. Part of the executive program is known as the system boot. When the power is turned on, this program loads into RAM those systems immediately needed to put the computer into operation. Another important part of DOS is the auxiliary system file. This file contains commands and routines needed to execute user programs. These special file programs are usually resident in RAM only when needed and are called by the executive program. Library commands are specific DOS operations for executing special operator commands. They are also called by the executive program. Most DOS packages include utility programs that are called by typing the program name. Backup, copy, and format are examples of useful utility programs. Here is a quick overview of some of the operations performed by the disk operating system. Interfaces the CPU with the input, output, and storage devices. Accepts and interprets user commands. Guides programs in and out of the execution sequence. Oversees foreground and background computer tasks. Provides routines which would otherwise need to be included in every program, saving both memory and programming time. One way to understand a typical DOS and to envision the work it performs is to think of it as the manager of a commercial building. The building manager knows all the things you require him to do, and he does them faithfully if you remind him. In this analogy, the manager is the disk operating system. You are the computer operator. The building is the storage capacity of the diskette, and the tenants he works with are data. The first thing you want to know upon taking possession of the building is who the tenants are and what office spaces they occupy. The manager prepares a directory which tells you who is where. He also assigns tenants available space and makes sure each has enough. The DOS directory program lists all files contained on the diskette and displays their name or file spec on the video screen. It also indicates whether it is a program or a data file. It will usually give an indication of the amount of file space used by each file. There is no need to have your building evaluated by outside experts. By checking thermostats, monitoring smoke alarms, exits, and entrances, the building manager confirms that everything in the building is running smoothly on an ongoing basis. Most DOS packages have diagnostic and testing programs designed to give various data on the status of the DOS, the disk drive, and the computer, and to pinpoint trouble locations to assure the operator that everything is functioning correctly. Our building manager has extraordinary powers. He will, upon command, create an exact duplicate of your building and the tenants, which can be kept in reserve in case something should happen to the original. One of the most important utilities found on most disk operating systems is known as copy or backup, which makes it possible to make an exact copy onto another diskette of all the information contained on the original diskette. A backup copy is insurance against the accidental loss or damage to the original diskette. Upon your command, the building manager will add new tenants to the building and assign them space as needed. DOS will take a program or data that you have input into the computer and write it onto the diskette upon your command. It will save it either in a new and unused file or add it to an already existing file depending upon your command. If you wish to have a tenant evicted from the building for any reason whatsoever, the manager will do the job for you without asking why. DOS will delete or remove from the diskette any file or program no longer needed. If you want to replace, change, or add to data in a particular tenant's file with new information, the manager will do the job for you, then return the tenant to his old location or give him a new one, depending upon your request. Upon the issuance of the proper command, DOS will write any particular file into the random access memory of the computer where it may be operated upon, and upon command, DOS will return that file to the diskette using the same file spec or a new one, and place the proper information in the diskette directory. If you want to know how much free space remains in the building, the manager will add it up and present you with a display of available space. Upon command, DOS will give a visual display on the video screen of the used or unused space remaining on the diskette. Depending on the manufacturer of the DOS, it will be listed in sectors, bytes, or even in a unit known as grands, 5 sectors or approximately 1,280 bytes. If you are in a crash and lose your memory, the building manager will restore it completely when you check out of the hospital. If all programs or data in memory are lost in a crash, such as through some operator error or through an external occurrence such as an electrical failure or power surge, DOS is able to restore the programs upon issuance of the proper command. Best of all, our building manager is a very down-to-earth fellow and will speak to you in basic English when he needs to communicate with you, even though that is not his native tongue. The majority of DOS packages available for microcomputers are written in machine language, a language not readily understood by most computer users. However, when it is necessary to communicate with the user, the DOS will transmit its message in BASIC and will accept the answer in the same form before translating it to machine language, which it uses to execute commands. These are but a few of the functions performed by most DOS systems. There are wide differences in disk operating systems from manufacturer to manufacturer. Often, for the same microcomputer, there may be several disk operating systems available, varying from simple to extremely complex. When choosing a DOS for your computer, be sure to study the manual carefully. Make certain that it will perform all of the operations which you need now and all additional programs you will possibly need in the near future, but which will not be overly complicated for your requirements. Once again, remember that the disk operating system is software that makes possible all operations of which the disk drive and the diskette are capable.